In this example, we're given a graph to work with, and we're asked to determine a couple of things about the function given that graph. First off, they want us to determine the intervals where the function is continuous. So where is the graph continuous? But then they also want to know any place that it's not continuous, they want us to tell them why it is not continuous at those places. So let's take on the easier piece of this first, which is finding the intervals where the graph is continuous. Finding where the graph is continuous, it's easiest to find the places where it's not continuous. The places where it's not continuous are the places when you're drawing the graph that you would have to lift your pencil. So anytime you have to lift your pencil to draw this graph, that's going to be a place where the graph is not continuous. So drawing this graph, I would start over here on the left and I'd draw, and at that point right there, at x equals -1, I'm going to have to lift my pencil to start drawing the other part of the graph. So I know I lifted my pencil at x equals -1, so that's a place where this graph is not continuous. I keep drawing, draw. Then up here, I have to again lift my pencil to put that dot down right there. And so that's going to be another place at x equals 2 where I had to lift my pencil, and so the graph is not continuous. And then I just keep drawing, and everything else is fine. So coming back through and giving them the answer of where are the graph continuous, where is the graph continuous, the intervals, we would start and we would say, okay, starting out here at -infinity, because we're talking x values here. Whenever we're talking intervals, we're talking x intervals. So starting at -infinity, everything was fine until x equaled -1. And at that point, I had to pick my pencil up. So I would put a parenthesis around that -1. Remember, parentheses mean it's not included. A bracket tells us that it is included. So I don't want to include -1. Then I put a union symbol. It would start again at -1, and then it would go until 2. And then again, use the parenthesis at 2 because I had to pick my pencil up there. And then union that with starting at 2 and then heading off here to +infinity. And so that would be our intervals where the graph is continuous. Now we go on to the second part of this. The second part of this wants to know why it's not continuous at the specific places we said. So to do that, to show them why it's not continuous, we have to use that formal definition of what it means to be continuous. So for something to be continuous, the math definition says the limit, the overall limit as x approaches some number of f of x, that has to equal the function value at that same x value. So notice that that is the same value as that. What I always say is the limit needs to equal where the dot on the graph is, where the y value is, where you would put the dot. So to do this, we'll take on our two scenarios. So first scenario we'll deal with is the x equals -1 scenario. I always start by really using the limit portion of this definition. So what we would do is we would say, okay, the limit as x approaches our number a, which is -1 in this situation, what is the overall limit as x approaches -1? To answer that overall limit question, we have to find out what does our left-hand limit equal, and we also then have to figure out what does our right-hand limit equal. And are those two things equal to each other? So coming and looking at our graph, finding our left-hand limit, the limit is as we approach x equals -1 from the left, we would say I'm drawing, coming in from the left, it looks like I'm headed towards a y value of -6. So my left-hand limit is -6. Finding the right-hand limit as x approaches -1, coming in from the right, I can see that I would be headed towards this value here, a y value of -5. Since those two values are not equal to each other, that tells us that the overall limit does not exist. So the limit as x approaches -1 of f of x does not exist. Well, if the limit doesn't exist, you've failed the first part of your limit definition for continuity here. So we know that x equals -1, it's not continuous there because the limit did not exist there. Now we'll go and do the same game. This time we're working with our other value, where we said it wasn't continuous, at x equals 2. So again, I always start off with that limit side, and I would say this time I'm looking at the limit as x approaches 2 of our f of x here. So process for an overall limit, again, we have to go out and we have to determine what is our left-hand limit equal. We have to then determine what is our right-hand limit equal. And then we ask ourselves, are those two things the same? So this time we're looking at x equals 2. So I always kind of draw a wall there when I'm doing my limit problems. And I say, okay, as I approach that wall from the left, so drawing along this graph from the left direction, it looks like I'm headed towards this y value here, which would be 4. So my left-hand limit is 4. Coming at it from the right direction, I would come, and it also looks like I'm headed towards that same position. It looks like I'm headed towards 4. So in this scenario, there's nothing wrong with our limit. Our left-hand limit equaled our overall limit, which tells us that our overall limit is that same value, that value of 4. So the left side of our definition says that it equals 4. Now what we need to do is we need to come back in and we've got to look at this right-hand side. We want to know where is the dot? What is the function value? So we're asking what is f of 2? So it's saying when I plug in x equals 2, what is the y value that I would get out based upon this graph? So if I plug in x equals 2, my dot is actually at that point right there. That point would be a y value of 2. So at x equals 2, I get a y value of 2. The final part of this process is to now compare my two values and see if they're the same. So my limit answer said my overall limit as x approached 2 of f of x, that was equal to 4. The second part of the definition, where is the dot at, f of 2 told me that was a y value of 2. Well, what we can see now is that those two things are not equal to each other. And because my limit did not equal, my dot on the graph did not equal the function value, I know that the graph is not continuous at x equals 2. So finding where it's continuous, just looking at the graph, finding the intervals, pretty straightforward. You just want to identify any place that you would have to lift your pencil to draw the graph as a place where it's not continuous, and then don't include those in your x interval. And then if you need to show y, it always goes back to that definition of what it means to be continuous. You have to show them the limit equals the dot on the graph, and if it fails, either one of those situations, then that is why it is not continuous. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.